thematic mapping. You all might be thinking that why it is need of the hour now. We have been well versed with the live monitoring and the prediction of air pollution through various models, but unless until we connect it to the Google map, unless until we connect it to the real-time analysis and make it known to the public and make it known to the government organizations and simplify the process of predicting the air pollution before an international patient comes into India, whether he is entering into a very highly polluted area or non-polluted area. For all this kind of an advanced decision making, the online air pollution prediction and mapping, the real-time prediction and mapping is very imminent. So therefore, I have chosen this topic, and you all might be aware the Tamil Nadu Pollution Control Board is having a carrier center. That's the monitoring of pollution can be diagnosed. It can automatically be known to the member secretary's office through that process. You can understand those, but that is only a diagnosis. It can just display. It can't predict, and it can't map it, and it can't make any kind of hello. Now our meeting it's not been well demonstrated on the prediction of the pollutant. It will show you the real-time monitoring of the data and whichever the locations are. But what we are going to talk about today is interactive digital air pollution repository. So what is an interactive digital air pollution repository? We would be able to predict before you actually go into a particular location in advance, like a weather forecasting. We will be able to predict the air pollution forecasting. That's what the interest of this today's presentation. And this is the interestingly where I worked in the Central Road Research Institute. We had an air pollution mobile van. This is the van where I've used in the year 92, 93, 94.
Sir, excuse me, sir. Yeah. Your slides are not moving, and you are in the first slide itself.
Okay.
I think you have to. You can make it to the full screen. You know, if you can. And now it is there in the second slide, but it's still in the.
Is it the second slide now?
Yeah, it's in the second slide, but it's not the.
Moving? Is it moving?
Yes, sir. Third one. This is third one slide.
Yeah, this is the third slide.
Yes, sir.
Yeah, fine. That's how it is.
It's moving, sir, but it is. You will not come to full screen. Or the slideshow. I'm sorry. It's not.
It's not the slideshow. It's not in the slideshow.
No, it's not in the slideshow.
Oh, I'm in the slideshow only showing here.
Okay. Okay, then we'll adjust with this. Does not matter.
No, but the presentation will be very odd if it is so. How about it now?
It's a little bigger. Yeah.
Now is it in slideshow?
No, sir. It's not in slideshow.
Oh.
Minutes. You have to convert it.
How about it now? Dr. Lima, now it's okay?
It's no, it's not in slideshow still, sir. It's just a little bigger, but it's still in that format which we normally have for the presentation.
Yeah, okay, but it should be in slideshow mode. I don't know.
Yeah, it's still in the Microsoft PowerPoint format. It has not shifted to slideshow.
Now?
No, sir.
Sir, please click on the right side lower corner. Below
Yeah,
that one.
lower corner
Sir,
only.
this is.
Yeah, this is the right side lower corner.
Yeah, but it's not working.
The first one. You click on first one.
Yeah, right side lower corner. After 100% it shows.
Yes,
Afterwards the first one.
First one. 100% and first one.
I click the same.
Oh, achha. Okay.
Now I
Okay.
click the same. I click the same.
Okay. Yes. There is a problem. Okay.
Where the problem is with me or where?
No.
Because my screen it is slideshow. In my screen it is slideshow.
Oh, अच्छा. Maybe there is a problem. Some problem. ठीक है.
नहीं मैंने मेरे स्क्रीन पे अभी स्लाइड शो दिखता है.
Sir, why don't you remove and join again, sir?
Okay, I'll join again.
Yes, sir.
Yesterday, ma'am also had this kind of issues and they get done it.
Okay, I'll just leave, come out and join. Just a minute. Hello. Hello.
Sir, yes.
Yeah. The only meeting organizers and presenters can share like that. You have not given me the permission to share.
You're there, sir. You're there, the presenter.
Yeah, but the share button is not open. It says only meeting organizers and presenters can share.
Or just it because you're there with the presenter along with me. You're there. Only two of us are there, and you and me are there.
Yeah, but the arrow button, up arrow button, when I click it, it says only meeting organizers and presenters can share.
Oh, okay. You're there as presenter only. If I do anything, you'll become as attendee. Maybe I'll do that and then put you back as presenter. We'll see whether it works.
Yeah. It's not coming. Actually, the arrow used to be active the last time when I opened. Now the arrow looks very dull.
Yeah, yes, sir. Actually, you have see now, sir, whether you are there now.
Yeah, now I am there. Yeah.
Yeah, because you have come in through two in the thing, so that was the problem.
Okay. No problem. Can you see the slide?
No, sir.
Now?
Now also it is the same like what it was earlier.
Yeah, now?
The full, I mean, the slideshow is not coming up.
Yeah, for me in my slide, my computer, it shows slideshow.
It's okay, you can make it little bigger like you did last time, sir, 100%, and then we can proceed. Yeah.
This is okay?
The earlier one you had it, that this is okay.
Okay. This is what it is, Central Road Research Institute, where it has made me to work on it for a period of 8 years, and then I came out with a lot of air pollution studies, and since then I've been continuing this work. That's what I'm going to make a presentation to you today. And this is normally the air pollutant from complete or incomplete combustion. How the carbon monoxide, oxides of nitrogen, particulate matter, sulfur dioxide, and unburned hydrocarbons are tend to emit from the combustion or incomplete combustion of the process. So when we have the fuels like carbon, hydrogen, nitrogen, sulfur, and oxygen, if the oxygen is insufficient, the unburned hydrocarbon will be high. If the oxygen is sufficient with the stoichiometric, then obviously the carbon dioxide will be high. So the unburned hydrocarbon, carbon monoxide are the two major carbon-based pollutant it comes out. And of course, the sulfur with oxygen combines and forms sulfur dioxide. And of course, with the nitrogen forms nitrogen monoxide and nitrogen dioxide. So carbon monoxide, hydrocarbon, unburned hydrocarbon, oxides of nitrogen, and sulfur dioxide are the four primary pollutants. Normally, it affects the human system. Whereas the carbon dioxide, it affects the global warming potential. So the air to fuel ratio and the stoichiometry of the octane or decane becomes an important issue for a lean mixture, a rich mixture for emitting the unburned hydrocarbon or carbon monoxide. So the more air, more nitrogen emissions will be there. So this is a simple concept of how the sulfur dioxide, for example, if the coal is there, there is a lot of sulfur contained in the coal. So therefore the sulfur dioxide will be high in the thermal power plants. In the vehicles, in the vehicular pollution, the old vehicles emits a lot of carbon monoxide and unburned hydrocarbons. So the heavy vehicles generates a lot of oxides of nitrogen. So therefore these pollutants, when it is processed, when it is combusted, it is emitted, transported, dispersed, diffused, and deposited. These are the 5 important processes that it undergoes. Emitted first. What is called emission? The emission of air pollutant, there are 3 and 4 types of emissions. One is point source, line source, multiple point source, and fugitive emissions. What is point source? Any chimney or a stack or any kind of tall single source of emission we call point source. What is line source? The vehicles, when it pass through the highways or the roadways, we call that pollutant emission as line source. And multiple point source, where there is an industrial complex, UPSADC, MPSADC, Tamil Nadu State Industrial Development Corporation, SIPCOT, all those places where the multiples of stocks are there, we call it multiple point source. And the fugitive emissions is like dust on the road and the foundries and the glass and ceramic industries, where when the grinding process or when in the aberration process emits a lot of dust particles, and the emissions are called fugitive emissions. So this is what normally we call it source emission inventory. What is called source emission inventory? Whenever the pollutants are comes out from any source, what is the strength of the source? What is the strength of the pollutants arising out of a point source, line source, or multiple point source and fugitive emission is a very important parameter to model it and to predict it. So these emissions are depends on internal temperature of the stock, chimney, and auto exhaust. Exit temperature leads to exit velocity, and exit external temperature and diameter of the stock are the major process that it depends on the emission velocity and the further processes. The transportation or the transport of pollutant, the third important one is called the transport of pollutant from chimney or a stack. When a chimney is emitted, the next process is called transportation of the pollutant. Where it travels, and that's called upwind, and the distance it travels and finally it ends in a deposition is called downwind. So when the upwind direction, from the upwind direction, how the wind is flowing, according to the wind direction, the pollutants will flow and the plume will flow. So the local wind speed is an important parameter, what wind speed it is, what miles per hour or not, and what is the wind direction. There are 16 directions of the wind: southeast, south-southeast, northeast, north-northeast, east-southeast, like that there are 16 directions. So the 360-degree angle of the globe is divided into 16. So 16 directions are there. And the temperature is one of the important phenomena when it travels the pollutant, and the pressure, humidity. If it is in the mountain, it straight away comes down or it goes up. And the coastal zone, so particularly when the Chennai city is located in the coast has got the tendency to receive all the pollutants because of the breeze when it goes inside. And when the breeze comes out, it takes little, but more often when the breeze goes inside, it takes the pollutant into the sea and the valleys and the terrains. So these are the transportation of the pollutant from what distance it can travel, particularly if the wind speed is very high, it can travel to a long distance. If there is no wind speed, it cannot travel to a long distance. So the next one is dispersion. So first I said emission, second I said dispersion, transport, and the third one is dispersion of the air pollutant. These depend on atmospheric stability. What is called stability of the atmosphere? It is the tendency to resist the dispersion of the pollutant or enhancing the dispersion of the pollutant. Scientifically, I just wanted to tell you one thing. When the earth is heated up, there is a buoyancy force comes out from the earth. And that buoyancy force is called the temperature lifting, will take the pollutant to the higher altitude. If the earth is not heating up, there is no buoyancy force, and whatever the pollutants emitted from the chimney or automobile industry or wherever it is, and the automobiles, and it exists as it is in the lower atmosphere. But the atmospheric stability is the important parameter to decide the dispersion of the pollutant and to decide the maximum ground level concentration of pollutant near the chimney or near the road or far from the road, and the stability is one of the important parameters. And again, the wind pattern in the sense, it has got a wind speed and the wind direction to put together. We prepare a wind rose. What is wind rose? It says according to particular location and which direction it travels the pollutant, at what speed, that we call it wind pattern or wind rose. And the dispersion coefficient, of course, sigma y and sigma z values are very important parameter to predict the dispersion of the pollutant, and the sigma y and sigma z values. And the environmental process lapse rate, that's what in the first instance I said, temperature and the temperature lapse rate. What is temperature lapse rate? As you go to higher altitude, the temperature will be decreasing. Probably you might see the Ooty is around 2000 MSL mean sea level, 2000 meter. So every meter, there is a 0.9 degree or 0.8 degree centigrade decrease, and that is called atmospheric lapse rate. So if you go for 100 meter, so roughly one temperature will be decreased. And if you go to 200 meter, 2 degree will be approximately decreased because 0.9 degree centigrade per every 100 meter. So likewise, if you keep on going 1000 meter, 10 degree will be the decrease. 2000 meter, 20 degree will be the decrease. So that is what is called environmental lapse rate. And what is called process lapse rate, when the parcel of air pollutants comes into the atmosphere, at that particular time, because of the heat in the parcel of air and how that temperature decrease, and that is called process lapse rate. So that one is called environmental lapse rate and another one is called process lapse rate, are the very important parameter deciding the mixing height of the atmosphere, and that mixing height is actually decide the dispersion pattern of the pollutant. So that is what the next parameter is called mixing height. So the environmental process lapse rate, and the process lapse rate put together, it decides the mixing height. And the mixing height decides the ventilation coefficient, and of course the solar flux and sunshine data. For a simple understanding to all of my participants, I wanted to tell you the unequal heating of the earth. The unequal heating of the earth leads to unequal temperature. The unequal temperature leads to unequal pressure, unequal density, and the unequal pressure leads to force, and the force becomes a wind. So therefore, the solar insolation pattern in the winter it does not have much of heating of the air. Is in summer it has high heating of the air. Therefore, the dilution and the dispersion of the pollutant is more in the summer rather than in the winter. So that is what how the pollutants are being accumulated or are being dispersed. So that is why it's very important to know online instantaneous stability condition, instantaneous mixing height, instantaneous ventilation coefficient, instantaneous wind speed and wind direction data to predict the pollutant in a Google map and to show that I'm going to Avadi or I'm going to Ambattur in a particular place, and that place tomorrow evening, what will be the wind pattern, what will be the wind speed, what will be the mixing height, what will be the ventilation coefficient beyond, what will be the source strength of pollutant. And according to that, the Google map or the GIS, geographical information system based, the Google map should be able to predict the concentrations at Avadi. It is going to be like this. If I could get to know well in advance, if I get to know whichever the place I go, then I will be alert and make the better effort to take care of myself. That's one of the important objective of this today's presentation is. The next important thing is diffusion and deposition of air pollutants. So there are 5 important processes that it undergoes: emission, transport, dispersion, and then diffusion and deposition. So the diffusion and deposition, it depends on whether the pollutant is a conservative or non-conservative pollutant. Conservative means reactive pollutant, non-conservative means a non-reactive pollutant. So sorry, conservative means it's a non-reactive pollutant, non-conservative means it get degraded. Molecular density gradient, particularly for the pollutant, and the density gradient it makes quickly whether it settles or it floats on the top. For example, the particulate matter has got PM 2.5, PM 10, PM 100, and total suspended particulate matter and respirable suspended particulate matter. So the finer the particle, it tends to float on the air. It coarser the particle, it tends to settle down according to the Stokes law. So what we look at it, particle settling velocity is more important, and that depends on the aerodynamic diameter of the particle. So therefore, if the particles are very coarse particle, will tend to settle down quicker if the fine particles are tends to lose it. So tend to float in the air. So therefore, the important concept here, when the particles are settled in Taj Mahal, when the particles are settled in Srirangam temple, when the particles are settled in tall raised buildings adjoining to the traffic corridors or adjoining to the thermal power plant, and then the particle contains a lot of sulfur containing material or corrosive material, and the particular system get corroded and it get particularly the life is lost. So this is what how these pollutants are emitted. You can see here how the pollutant comes out, and you can see here how the turbulence happens on the top. And this is some of the Earth's process that I have told you. The unequal heating, if the heating takes place here, here it will be cooling. And if the heating takes place here, here it will be cooling. And beyond the local intrusion or local climatic conditions influence on the dispersion parameter, the global influence is approximately predictable. So this is some of the mapping scenario. Just I wanted to show you how this global warming mapping is done based on the legend. You can see here the red color indicates 5 to 10 degrees centigrade for every decade. So that is kind of a mapping scenario I'm showing. This is the because why we should so much importance to the air pollution instead of solid waste management or the water pollution. Whenever the water pollution is in the pipe, it can be controlled, it can be made into a detoxified substance. But in the air pollution, when it emitted to the atmosphere, it is not in our control. It is in the atmosphere's control. It is in the phenomena or the process of atmosphere or stability of the atmosphere's control that is going to play. So we need to have a better understanding, although we cannot have exactly so accurate understanding on how it is going to predict, how it is going to map it. But almost 90% to 95% of accuracy we can certainly predict. So these are some of the scenarios. And this is, I said, incomplete combustion of the fuels leads to a lot of carbon monoxide and hydrocarbon emissions. And that's what I wanted to mention it here. Photochemical smog forming potential in the urban atmosphere of any urban atmosphere during winter months. This is one of the important process and important concept that we all must be aware that the smog episode will likely to happen or not in most of the urban centers. particularly in Chennai. If you take the January 12th or January 10th, January 15th, in the morning it's very intense cold because you will feel a lot of foggy conditions. And that is what, when the vehicular pollution emits a lot of smoke and that combines with the fog, and that becomes the smog. When the smog exists in the atmosphere at more than 10 o'clock or 11 o'clock, when the UV rays and the sunshine rays are appropriate, then the photochemical reaction it triggers, and then ultimate end product of photochemical reaction is peroxyacetylene nitrate. That is why the peroxyacetylene nitrate was one of the major culprit, made a lot of lives in the Los Angeles smog and London smog. So therefore, if the Los Angeles smog and London smog are not to be occurred in our own country, we must be alert about how to predict the photochemical smog forming potential based on the different precursor pollutants that is being emitted from the vehicles or from the industries. So how this photochemical smog forms, actually, I just wanted to mention to you. The reactive hydrocarbons are emitted from the automobiles, and when it is emitted into the automobile, these are the principal oxidation reactions in the atmosphere. It happens when there is a nitrogen oxide or oxides of nitrogen or nitrogen dioxide is emitted to the atmosphere. The photon energy, it oxidizes and converts into NO plus O, and the atomic oxygen combines with the molecular oxygen, forms surface ozone. So when the surface ozone is high enough, particularly at between morning 10 o'clock to 11 o'clock at a moderate sunlight, and that again with the sunlight, again with the photon energy forms this. But this ozone, O3 in the surface ozone, actually oxidizes the hydrocarbon free radical. For oxidizing the hydrocarbon, the surface ozone is the biggest culprit, that it oxidizes the hydrocarbon and forms a free radical and forms a peroxyacetyl nitrate at the end, and that becomes a carcinogenic substance, and that gives a lot of suffocation and so many other natural diseases. So therefore, the photochemical smog is one of the important concepts that we all must address into it. So as this is one of the study when I was working in Delhi, I really triggered predicted the photochemical smog forming potential in the urban atmosphere of Delhi during winter months. Probably Chennai is not having that much cold, but in Delhi you will have a very intense cold. So the smoggy condition is very prominent particularly in Delhi, and the smoggy conditions leads to, because the Delhi is very heavily polluted, and even today every year in the winter months Delhi is facing a lot of air pollution problem, and it was not so around 3-4 years still because of the vehicular population and the pollution level control. But for the past 5 years almost, the pollution level is very alarming in Delhi, particularly in winter season. So therefore, the prediction of photochemical smog is very essential now, and very much essential to integrate the photochemical, because the prediction of photochemical smog or prediction of air pollution dispersion or prediction of the acuteness or the chronic effect of this air pollution is not only the concentration based. As I said, it also depends on the atmospheric parameters, atmospheric dispersion parameter based. So therefore, it is a multi-parameter linked. So in order to predict it, we have a lot of models, but the model output can give a single source, a single point. But unless until we synchronize that with the advancement in the IoT, then it becomes, that's the reason. Switch off. Yeah, the organization can switch off sometimes, right? Please switch on the mic. That people are in. So, Hello? 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 Hello?
Sir?
Hello?
Yes, sir.
யாரோ மைக் ஆன் பண்ணிருக்காங்க போல ஒரே நாய்ஸியா இருக்குமா?
Okay, I'll mute all of them, sir.
எல்லாரோட மைக் அன்மியூட் பண்ணுங்க. அந்த மியூட் பண்ணிட்டீங்களே.
I'll mute everybody, sir.
Okay, ma. Okay, because so far it was giving so much noise, ma.
Okay.
Okay. So this is what the work what I did, particularly the photochemical smog formation study work, and this photochemical smog formation study, particularly in the urban atmosphere of Delhi, made some alarming effect on in the year 1997, 98, 99. That has become an instrumental for implementing the compressed natural gas by the Supreme Court and the Central Pollution Control Board. We submitted a very nice report to the Supreme Court and the Central Pollution Control Board that time, and it was made clarified and felt the need for an alternative fuel. That is what the compressed natural gas becomes very prominent in Delhi nowadays. So this is what we made. The diurnal and nocturnal variation of atmospheric pollutant dispersions are influenced by the mixing height. The bimodal peak of carbon monoxide and nitrogen oxide that we have observed, high oxys of nitrogen was associated with the heavy vehicles. High stagnation of pollutants at 21 hours to 4 hours it was accumulated in the morning, early V hours, and high ozone formation at peak hours, but ozone quenching occurred at during noon hours. But ozone quenching means again dissociation of ozone becoming converted into different substance, and very less surface ozone formation at residential zone because there is no oxys of nitrogen and there is no dissociation of NO2 to or NO and O, and that's how the surface ozone is formation does not take place in that particular place. So that's what now I'm coming to the air environment. We have one called ambient air quality monitoring. There is a national ambient air quality monitoring station. NAQM is there. Particularly in most of the cities in India, we have online and it's all linked network system of ambient air quality monitoring for the gaseous pollutant and particulate pollutant. I've already mentioned primary and secondary pollutants. So the monitoring normally uses the high volume air sampler and the personal air samplers, particularly whenever they want to measure the pollutants in the close to the area, close to the workforce, then we must use a handy personal air sampler. Particularly when I did a small project in the BHEL Trichurapalli, where we have used the Casella 123 AFC personal air sampler, and that's a small handy sampler where we can use. In case if we wanted to use the particulate size distribution and elemental composition of the particles to understand whether lead content is very high in the particle and which size of the particle. So we must understand which size the particles are accumulated more, and then we must use an Anderson cascade impactor. With the 8-stage cascade impactor, it will have a different size of the filters, pore size of the filters in different level, and then it will suck the coarse filter on the top, next fine filter, next fine filter, next fine filter, like that. And 8 stages of the sizes it can filter out, and it can give us the composition in each stages and each sizes, and then we can quantify which actual substance is accumulated more into fine particle or in the coarse particle, and then we can study about the impact on it. So this is the sources, and I said anthropogenic and natural sources. I've already mentioned to you about point source, line source, and multiple point source. So the industrial complexes, what we need, emission load, or we call it source emission inventory, and the plume exit velocity, exit temperature, stack diameter, and stack height. And the air pollution from these sources, I told you, emitted, transported, dispersed, diffused, and deposited. So there are very importantly micrometeorology and macrometeorological parameters are very important. And micrometeorology, it's up to a distance of 1 kilometer, 1 to 100 kilometer radius, and 1 hour of hourly pollutant up to 24 hours. We can take and use and predict the micrometeorological models. And then macrometeorological into 100 to 1000 kilometer radius, and synoptic meteorology is 1000 kilometer and above years. So that is the regional intercontinental model, particularly for climate change model and other things that normally they use synoptic model. So micro scale, meso scale, and macro scale model normally we say, and the synoptic model, it's a global warming potential prediction and other things that they use it. So what are the meteorological parameters that can predict the air pollutant concentration? That's the temperature, temperature lapse rate, I told you about it, wind speed, wind direction, relative humidity, solar day data, UV radiation data, stability data, and mixing type data. So I mentioned unequal atmospheric temperature due to difference in buoyancy force, unequal pressure, unequal density leads to wind speed and direction. So this is the different structure, the vertical structure of the atmosphere. We say where we are living is called a lithosphere, then troposphere, tropopause, stratosphere, stratopause, mesosphere, thermosphere, chemosphere, and ionosphere. This is the vertical structure. Roughly 0 to 11 kilometer we call it troposphere, 11 to 50 kilometer we call it stratosphere. But we are all more interested only in the troposphere, that too in the planetary boundary layer. The air pollution problems normally is assessed, predicted, and modeled up to the planetary boundary layer. Roughly it is around 600 to 800 meter from the Earth. So that layer is called planetary PBL, planetary boundary layer. And this is the temperature lapse rate I mentioned. The rate of decrease of temperature with increase in height is called a lapse rate. And I told the lapse rate is environmental and process lapse rate. Thus, an atmospheric stability is one of the important parameters. A tendency of the atmosphere to resist or enhance the vertical motion of air pollutant or vertical dispersion of air pollutant. There are mainly 3 types of stability, that is unstable, neutral, and stable. What is unstable? When the earth is heated up, when the solar insolation is very high, and that increases the temperature in the lower troposphere, particularly planetary boundary layer, and that is called unstable stability condition. And what is neutral? Neither it is stable nor it is unstable. And I will tell you later with the figures how the neutral is. Stable, there is no buoyancy forces, no wind, no solar insolation, no wind speed, and it affects the vertical motion because the dispersion cannot happen. And it tends to give the maximum ground level concentrations because of poor dispersion. And this is some of the stability conditions we plot. And this is the strong and moderate wind speed. That's a daytime solar insolation and the nighttime insolation. And we take the cloud cover data, cloudiness data, and thin overlay cloud data. So if the wind speed is less than 2, 2 to 3, 3 to 5, 5 to 6, and above 6, what will be the stability if the daytime is high insolation? A, B, C, D, E, like that. So E and F are stable, extremely stable. A and B and C are moderately unstable, extremely unstable, and stable. And D is neutral normally. So this is what it is: extremely unstable, B is moderately stable, slightly unstable, and neutral, slightly stable, and moderately stable, and extremely stable. This is how we classify the stability conditions in the atmosphere. So as I said, stability is one of the very important parameter to decide about the dispersion of the pollutant. I already told you about environmental lapse rate and the process lapse rate. The environmental lapse rate is naturally when the environment rate of decrease of temperature, particularly if it is Chennai or if it is Trichy or if it is Viluppuram, there is a standard lapse rate with reference to months and seasons and the year of year. So if it is winter months, the lapse rate will be very quicker. The rate of decrease will be very quicker, and the rate of decrease in temperature will be very high, maybe 0.9 degree or 1 degree centigrade per every 100 meter. If it is highly summer, because of the heating takes place, it will be 0.6 or 0.5. So the rate of decrease with reference to the actual environment is called environmental lapse rate. And if it refers to the process parcel or instantaneously any day that we are going to do monitoring of air pollution or modeling of air pollution, that day we raise the helium balloon. Normally the helium balloon, it has got a thermistor on the bottom of the balloon. When the balloon is raised, it sends signal to the computer by an azimuth elevation point. And then the computer predicts the rate of decrease of temperature instantaneously. And then that is taken as a process lapse rate. So the actual environmental lapse rate is monitored here. And this is with reference to height. This is the temperature. So if it is 100 meter, 200 meter, 300, 500, 600 meter, whatever the height it is, the temperature is predicted. This is the temperature, 1 degree turn to 10 degree, 15 degree, like that is predicted, is plotted here. And then when the decrease in temperature happens, and when we plot both, wherever the height it get mixed, it get intercepted, that's called mixing height, which means the pollutants cannot disperse beyond this point. So you can see here, this is an unstable, this is a neutral, this is a weakly stable, and this is extremely stable condition. You can see the mixing height. This normally occurs during extreme winter months, and particularly in the midnight season, a midnight period, and that too in the winter month, the maximum mixing height is very low. And because there is not enough space to dilute the pollutant, it cannot go beyond it, because all these stability conditions will suppress back to the earth, suppress the pollutants to deposit back to the earth or to exist in the lower troposphere of the atmosphere. That's how the impact is more when we compare the other stability conditions. Whereas this stability is called neutral. You can see here nowhere it get intercepted. So the environmental lapse rate and process lapse rate keep on going up, but never it get intercepted. That's what the atmospheric condition is called stable. It's called neutral. So therefore, the stability is one of the very important parameters to decide about the maximum ground level concentration in a particular location, whether it is industry or the urban atmosphere. So I said windrows, it tends to predict the pattern, wind pattern, both in terms of direction and the speed. So I already talked about the maximum mixing height. The height was something where the intercept takes place between the ELR and the PLR. The height up to where the dispersion of pollutant can take place. So beyond the mixing height, there is no dispersion can take place. Higher the mixing height, more dilution and more dispersion of pollutant. And lower the mixing height, poor dispersion, high accumulation of pollutant, and the impact is more. So therefore, the stability and the mixing height and the ventilation coefficient is the parameters that has to be predicted through the meteorological data input. And now when we look at it with the advancement of the air pollution thematic mapping, advanced real-time monitoring and mapping, and we might have to give it to the NRSA, National Remote Sensing Agency, or the Regional Remote Sensing Agency, and then they should integrate this software of cloud computing, IoT, and this system, and to integrate the online air pollution monitoring sensors, and both should be integrated into your software, and then the software should be able to predict through the online NRSA data as well as online monitoring data synchronized together. We have to give a common concept of the equations and the models in there, and that model have to be online pre-diagnosed or pre-detected mapping system. That is what the focus of today's topic is. So I said point multiple and other things I mentioned already. And this is some of the control measures of centrifugal filters, particularly for industries. They got a control measures like electrostatic precipitators, backhouse filters, cyclonic filters. All those control techniques are available for the particulate and for the gaseous pollutants. And there are some of these pollutants when it exists in the point source or line source or multiple point source, the modeling concept is different for different approaches. Whether it is multiple point source or the line source, we use a Kalin 3 model. And if it is a multiple point source, we use a terrain model. If it is a single point source, we use an ISCST model, Gaussian distribution model. But all these models normally, whether it's a plume dispersion or a flume dispersion refers to air dispersion, and flume dispersion refers to water dispersion or effluent dispersion in a river. All those are based on the Fickian diffusion equation or the Fick's law of diffusion. Normally, most of the chemical engineers would have studied about Fick's law of diffusion, and that Fick's law of diffusion is actually used for the prediction of this model, particularly through a Gaussian dispersion model, because the sigma y and sigma z values are based on the stability. If it is wider, If it is shorter, the puff, and that's why we use the Gaussian dispersion model. So there are not only the Gaussian dispersion model, nowadays there are so many modeling softwares are in practice. ISCST model, HTM models, and CFD modeling. In fact, my wife, Dr. Lata, has used the CFD modeling for the prediction of air pollutants. And this is one of the work that she did, and we jointly made the air pollution dispersion models, and that is using the computational fluid dynamics techniques. And you can see how these pollutants, they used Fluent, CFX, or the Gambit, or the G-Shop, they used it to predict the air pollution modeling. And this is the prediction of urban photochemical smog also it can predict, and it can prepare a thematic air pollution mapping, because the CFD also is one of this good software that can be integrated into a ArcInfo or MapInfo. But once we digitize the any industrial site location or an urban site location, then we pinpoint whatever this monitoring station locations are. Then we can integrate the data into that. Then we can integrate the meteorological data onto it, and then it can give a dispersion modeling and mapping process that I'm going to show you. And we can also plot isopleth contouring at whichever the directions the winds are. So isopleth contouring is one of the very important concept nowadays to make contours of thematic contours to show exactly where the dead zone, where the red zones or green zones or yellow zones for a prediction of the risk in that particular factor. So this is the Gaussian plume model. Normally they use it, and as I said, Q is the source strength of the pollutant, whichever it comes from the chimney or wherever it is. It's meter per second, and it gives total. And sorry, this is the cubic meter per hour of the pollutant strength, and H is the effective stock height. So this is how they use the air pollution prediction model using the Pascal and Turner stability conditions and the Gaussian dispersion equations. So the parameters used in air quality modeling, there's a winter and summer and slightly moderate summer. So wind speed and stability, and stability in the night normally used to be in F, or if it is in summer, it used to be in E. If it is little rainy, it used to be in E, but F is extremely stable, particularly in the February month or the winter month. So the height of the stock is very important, and if the taller the height, because the design of the stock itself is a very important concept before they do a comprehensive EIA or a rapid EIA work. And this is the sigma with sigma z value predictions. And particularly see, because for Indian context, we take cloud cover data. Whereas whether the clouds are high, when I looked at the stability conditions predictions, it's based on the cloud cover, moderate cloud cover, intense cloud cover. But the real-time modeling has got a different process, that different parameters that we take into account for prediction of sigma y and sigma z. So these are the wind rose plotting system, and what are the directions that it can take? I said 16 directions: northeast, northeast, east, northeast, east, east, southeast, southeast, south, southeast, south, and south, southwest. Likewise, in the 16 directions, we plot the wind rose. And of course, I said about the mixing height for dispersion modeling, and the buoyant energy available from the below the mixing height is actually helps for the dispersion of the pollutant. So this is the typical plume dispersion. This is the typical plume. Actually, the color is little hiding, and the plume is dispersing like this, and it shows whether the dispersion is because of the exit temperature, exit velocity. It can go to high altitude, so it forms like a puff. It forms like a Gaussian puff, and that's why it's Gaussian equations we follow. So this is the different grid. We can say downwind distance x, y, z coordinate, and this is the x coordinate, and this is the downwind distance in meters. So here you can say the point source pollutants are emitted based on the wind speed and wind direction, which direction it travels. You can see here, this becomes a point source, and this becomes the left and the right, x and y directions, how the pollutants can travel based on the wind speed and direction. So this is again the dispersion phenomena. So you can see here, this is simple mapping. The wind direction is from here to here, this side, and the red zones are the actual zones where the pollutants are high concentrations, and you can see here up to 4.5 it has shown, and there is little yellow here where 5 and 5.1 also, and you can see these other areas are blue. So like the dispersion of the pollutant based on the wind direction and the wind speed, this is the simple model in a particular intersection or near the hospitals or near the place, but it is only at one time live modeling, but which is not connected to the advancement of the cloud computing or IoT or artificial intelligence. So whereas here, when you look at it, if you make a single model and connect it to different corridors, the entire city can be mapped. So based on that, this and this contour can be made, and this contour can be made. That's what you are going to see now. You can see SO2 contours. You can see SO2 contour in the month of August. So this is some of the CFD modeling based conclusions. Of course, CFD is a very versatile tool that it can predict the air pollution dispersants very nicely. And there are other types of models also, like numerical grid model, stochastic model, empirical model, physical model, and apart from the Gaussian plume dispersion model. And this is the spatial distribution of respirable suspended particulate matter. So the second type of model using numerical methods or the finite element analysis, we can use this model and predictions on a particular wind direction. And this is the spatial distribution of suspended particulate matter. At 5 monitoring sites, we can see here the 5, 1, 2, 3, 4, 5. You can see how the cumulative pollutants of particularly this 200 microgram per cubic meter, it is occurring here. So that's what it's a cumulative impact zones. So you can like this mapping can be done for the SO2 5 monitoring sites, and again 5 monitoring sites. So this is the how we can predict these pollutants. That's what now we are actually coming into the advancement in artificial intelligence, cloud computing, and IoT synchronized air pollution thematic mapping in the real-time mapping. So particularly in Bihar, the Patna news, it says very nicely, artificial intelligence to detect air pollution sources in Bihar. The Central Pollution Control Board had issued a good directions for moderating the bid claims to set up an AI-based prediction of air pollution models. So the Bihar State Pollution Control Board is all set to use artificial intelligence and remote sensing technology to detect key source of air pollution in the state through satellite imaging and real-time monitoring. So this is more important, the satellite imaging and real-time monitoring using artificial intelligence, the Bihar State Pollution Control Board is going to follow. So for this, the Bihar State Pollution Control Board chairman, they have made, along with the UNDP and the University of Birmingham, joined together, and they made an advanced real-time air pollution monitoring and mapping and modeling. So this is some of the. So why now to link real-time air pollution data for the advanced online prediction, connecting through cloud, IoT, and artificial intelligence into Google air pollution mapping. So we know Google mapping to go from one place to other place. Can we have Google air pollution mapping similar to this? That's what the intention of it now. The artificial intelligence, this work is much well appreciated and is done for the Bihar State by the Bihar State Pollution Control Board. And the researchers also use cloud computing and IoT. And the Loughborough University in UK also uses the Baba Newton Fund. They use the advanced artificial intelligence and cloud computing based air pollution prediction systems. So what are some of the diseases? Because before I show you some of the AI or cloud computing based case study and modeling, these are the important pollutants of PM, ozone, and NO2 gives different diseases. And this is the standard Central Pollution Control Board standard for every pollutant, sulfur dioxide, oxides of nitrogen. So we all must have it as a reference standard. And most of the Indian citizens, they must know at what is the concentration of sulfur dioxide and oxides of nitrogen in PM10 and PM100, minimum threshold or standard values that they are not supposed to export beyond that. So you can see here the 2.5 micrometer or PM 2.5 for 24 hours, it's only 60 microgram per cubic meter. And if it goes beyond, it becomes dangerous. So ozone, what is the standard? Lead, carbon monoxide, and carbon dioxide is 0.02%. That is the standard. So this is the ready reckon standard. Normally, we all must be having it to use it for our standard reference. So this is what I said about windrows. This is the windrows, goes from the direction which it flows. And this is, for example, northeast, I can say. So the wind is coming from northeast to this direction. And this is the distance like yellow. You can see here 2.1 to 3.6 wind speed is the miles meter per second is the wind speed. And you can see here this distance is percentage of that wind in that particular direction, which means around 3.6 to 5.7 meter per second. And this meter per second will takes every distribution in every distance. So this, the red one is actually the maximum, and the blue one, there is no blue one here. It is above 5.6 meter per second. It's not there at all. So this is some of the sources. These are the different models being attempted. ISCST3, ISCST3, PAL model, FDM model, CDM model, ADM model. So there are Kalin 3, Kalin 4 models. There are so many models are being used, are being practiced nowadays. So there's mathematical models. The industrial source complex models are developed by US Environmental Protection Agency. And now it's well uniformly followed by so many, the whole country we follow ISCST model very much. So the equations for the ZLC and the method of images, pollutant decay, we can calculate. Of course, ISCST model, this is a simple model. ISCST short-term model, ISCST short-term model. This is again the short-term model for predicting different intersections and corridors. And ISCST short-term model. ISCST short-term model based on the wind profile. We can calculate, based on the wind profile, we can calculate the stability category. This is the kind of calculations based on the rural exponent and urban exponent. These are the standard values we keep it for Indian context, and then we calculate the stability category, whether it is A, B, C, D, E. So this is the plume rise equations beyond the height of the plume, how much is the distance it can go up. The plume rise in the neutral and the stable air, how the stable and the neutral air it can disperse. So this is what I was showing about the pattern of the plume, and the height between this exit stack and the height up to here is called plume rise, and the plume rise happens based on the internal temperature. If the temperature is very high, the plume rise height will be very high. If the temperature internal is very low, because it gets neutralized with atmospheric temperature, and the bend will take place immediately. So this is the plume pattern, plume dispersion pattern. So then it can go, but when the resistance in the upper atmosphere happens, it can come down, and partly it can settle down somewhere here. So this is ISCST model. This is again ISCST model. So dispersion parameters, what are the parameters that we use? Again, of course, sigmoid z values are a very important thing that we normally calculate, dispersion coefficient in X and Y directions. And this is in the rural areas, in urban areas. How sigma y, sigma z is calculated based on the Q value. You can see how these Q values are used in different locations. So hourly data comprising of these we normally need it. Precipitation index also is needed, some of the modeling input. So the point source, so location of the stack, stock height, stock temperature, stock gas exit velocity, and stock gas exit temperature, emission rate of pollutant, that's gram per second, is an input parameters that we need it. And the area source, location of the area, emission rate, and release height above the ground, length of x direction and y direction, that's the downward distance, and the initial vertical dimension of the plume source. And this is the ISCST model input. What are the input data we require? And it's open air sources, location of the open pit, and ISCST model inputs again for different conditions. So regulatory default options: use stack dip downwards, use buoyancy induced dispersion, do not use gradual plume rise, use the COM processing routines, use upper bound concentration estimates, particularly in the upper bound layer, use default wind profile exponents, and that's a very minor thing. So some case studies you can see here. So this is I like Indraprastha, the thermal power station. You can see how it is coming out. So this is the calculations of the source emission inventory. So as I said, location, and this is the cup anemometer and wind van to know the directions, because this is actually it's going to give, and it has a process control system. It has got a microprocessor based data logger, and the data logger based on the direction. So this is actually the one shows the direction. The bottom one shows the wind speed. This is the cup anemometer. We call it anemometer, cup anemometer, and this is a wind van. So the anemometer is to measure the velocity of the wind, and the wind van is to measure the direction of the wind. And it gives an automatic data collection east, south, east at 5 meter per second or kilometer per hour, or by knot value. It gives continuously and get printed and recorded. And then the adjoining area, we can also measure the pollutants. It's done already. And the pollutants measurement and the micrometeorological data synchronize together and use it in the model. And of course, we need a helium balloon raising data and the azimuth elevation with the environmental and process labs rate. Also, we need it to understand the stability conditions. So this is emissions used for different predictions. We can change permutation combinations with the emission factors, with the emission load, and even sometimes what I interestingly do it using an Excel sheet. I create an equation editor and create a lot of equations in there, and I get different downwind distance and the different upwind distance I feed into from the point source, and we get a maximum ground level concentration based on the sigma y, sigma z, and the stability parameters that we are going to feed in. And but what is interesting, this model can take every parameter, including the mixing height, including the ventilation coefficient data, and predict the more accurately than in the Excel sheet. So this is the windrows pattern, which I mentioned already. So this is the hourly meteorological data you can see here, and this is the wind direction, 45 degree, 45 degree, 45 degree. So you can see 45 degree exactly towards northeast. So likewise 360 north. So you can calculate and find out what exactly the direction of the wind is. And of course the temperature, and of course the stability is 1, 2, 3, A, B, C, D, E, F. Normally we made here as the 1, 2, 3, 4, 5. And this is the mixing height, 150 meter, 130, 80 meter, 150, 400 meter, and 600 meters. So you can see where the temperature is very high, and obviously the mixing height also goes towards up. So this is a kind of mapping you can see here. It's a kind of thematic mapping. You can see here this particular contours have made the direction flows from this direction to here, and this pollutant accumulation is happened in this location. There's not much here. And similarly, the pollutant accumulation happens in this location. So it has happened here. It has happened here. It has happened in the blue color. It has happened here. Nothing happens in this region, opposite. So you can also look at the windrows, what you have made. You can also look at the output of the ISCST model prediction, what the mapping, what we have made. So it both should exactly coincide and show exactly the same direction as the windrows is, the same direction the dispersion pattern also should show. So this is the predicted maximum concentration with annual coal consumption and with coal consumption, and this also with coal consumptions. Is the stock emission data. So normally we need height of the stock, we need internal diameter, we need exit velocity, we need exit temperature, we need SO2 concentration, NOx, SPM, SO3, and NOx and SPM concentration. All these concentrations in terms of gram per second from the chimney, from the chimney, not in the atmosphere. From the chimney it is needed, and then these data can be used as an input for modeling. So stock emission details of ammonia, wherever there is much of ammonia content is there, it can predict and give you. So the total emission of pollutants before and after revamping. It is actually a case study that we have done, and before and after revamping, how these pollutants are dispersed and came down. This is the windrows pattern and the climatological conditions, how it favors the dispersion of pollutants. This is the atmospheric inversions, what happens in the different time interval, different solar insolation data. This is now before, after reform, and before reform existing. You can look at it how this dispersion pattern is. There's not much here and much here, but most of the things comes into this red area. So this is an existing between after revamping, existing after revamping, existing after revamping. So this is the predicted concentrations in terms of ISCST model, and the maximum ground level concentrations before and after the revamping. So you can see here distance from the ground level concentration in kilometer, dispersion from plant, and GLC ground level concentrations as nanogram per cubic meter, and the distance from the place to the downwind distance, how much we have taken for predicting this concentration, and dispersion from the plant also we have taken. So how much is the intercept of the normal area we get it, there the dispersion pattern we predict whether it is higher than the maximum ground level or lower than the maximum ground level concentration. This is some kind of shoreline fumigations, predicted maximum ground level concentrations. You can see here little negligible, in fact the NOx is very high. Of course the ammonia content was high. Of course from the naphtha plant, this is the model derived from the case study. So this is also a model derived from case study. So fugitive dust emissions, particularly in the foundry industry and in the semi-arid regions, a lot of dust storms and dust materials, it makes the fugitive emissions. What we call uncontrolled emissions are called fugitive emissions, or otherwise we can say natural emissions like dust particles and other things. So this is the mine emissions from the mine industry. For mine industry. So the application of FDM, you can see this again the windrose pattern. The earlier you have seen in this direction, now you can see this direction. So this is how actually this is how they linked both internet-based online monitoring and surveillance system and the NIC based modeling and mapping system. They integrated using different software, but it can make models on the basis of the input data. But it cannot predict the micrometeorological data, what is going to be tomorrow, like a weather forecasting. And it cannot predict the concentration of air pollutants like what is today, tomorrow, because the scenario analysis of in the whole seasons, different seasons, we have to make it. And that we should give it as an input after getting the NRS's micrometeorological data. Then when we synchronize both together, and then we can get an advanced mapping for tomorrow or next month or like that. So comparison of ISCST and the FDM model for particulate matter. So general information, it's a source, receptors, meteorology and deposition are the important process. Receptor and meteorology are the rather very important process. And the regulatory models, how it works. I shown you a two kind of white colored table. That's the regulatory norms which Government of India makes through Ministry of Environment and Forest and Central Pollution Control Board. And that's the environmental law that is based on EPA 1986 based act, and that they defined. This is an ISCST model and FDM model. It's a comparison, ISCST and FDM model comparison. ISCST. So it's again a comparison. So prediction of particulate concentration due to fugitive emissions, they use ISCST 3 and FDM model for particulate pollutants. This is again a mapping, so you can see how many microgram per cubic meter, and this you can see roughly 4 microgram per cubic meter, it's 8 microgram per cubic meter. That means you can look at it here. There is no 8 or 7. So here there might be a residential area. That's why the pollutants level are not that much acute concentrated. Yeah, of course, mining activities in different places again. During a winter season, you can see here how this, because the calm condition becomes almost 0. So the diurnal concentration in the daytime, how the dispersion on the isopleth contours we can make, we have made it. So the contouring. Of course, the Kalyan-3 model, highway air pollution model, or the traffic air pollution model, we count the traffic, we count the idling, acceleration, and cruising conditions. We do an online monitoring using a static dynamometer, and take the monitoring of all these pollutants from the source, and also do national ambient air standards, ambient air monitoring. Both we synchronize together and predict a model. So of course, the Kalyan-3 model, it is only meant for vehicular pollution. We use a line source or Kalyan-3 model to predict the maximum ground level concentrations. And this is the elemental strength of each parameters, how it is. So that is what you can see. This is an equation. So the mixing zone model, I said about mixing height and ventilation coefficient, or the mixing zone model for using, because we can predict the lapse rate, but the vehicular pollution is not in a single chimney. It goes to the high altitude because it gets dispersed on the surface, and that is the modeling is a little bit different. What we made a multiple point source or point source models, and this is a vertical dispersion curve. So this is the source data, road endpoint of coordinates, traffic volume we need, emission factors we need, and number of line sources, number of receptors, number of hours of meteorological data, surface toughness, averaging time, and ambient background concentrations, wind speed, wind direction, atmospheric stability, mixing height, and the location of receptors. So these are some of the pollutants and the dispersion level, and this is before prediction, and this is after prediction at Sriharipuram and some of the places where we have done. So we are not actually looking into this. So what are the different concentrations at different locations in the morning and the evening? Is the predicted concentrations we can have it, and so these are some of the. This is a simple algorithm that it is being developed for connecting IoT and connecting artificial intelligence and connecting the sensor, air pollution monitoring sensor. So if all three are connected, and if it is connected through satellite remote sensing agency by imaging as well as by monitoring, then it is very easy to predict. Next week temperature we are able to know in advance, and that's why whether we need to go Ooty or we don't have to go to Ooty, or it's a rainy season or non-rainy season, and what is going to be the weather next week we are able to predict. The same way, what is going to be the air pollution concentration on next Friday in a particular location, we should be able to predict well in advance by keeping the source emission strength as well as the ambient level as constant. So that's the dimensional plume showing with the different movement of suspended solids, how it travels from the trajectory path of XYZ coordinates, how it travels from the point source. This is what it depicts. So how it travels from the point source, whether it's go to high altitude or high latitude, it settles well as get broken of the parcel of air, and that's how it shows. So this is the various concentrations of downwind distance. This is the various concentration of downwind distance, and some of the results what we have shown. So impact on the network, like whatever the confidentiality of the data, of course we need to make an end-to-end encrypt, and we should be able to protect it to make a Google map within our own country. We can protect the security very much using this. So this is the impact predictions. This is what exactly the artificial intelligence and cloud computing based connected mapping and the modeling here. So this you can see particular mapping in a particular location. You can see here this the entire city, and north, west, east, south. You can see the red color is 155 to 309 milligram per liter of carbon monoxide, and this is the violet color, particularly it is in here. You can see 492 to 1,613 microgram per cubic meter or milligram per liter. And this is what the predicted data it is. And this is what we call it thematic mapping, air pollution thematic mapping. So it can have a sulfur dioxide, it can have oxides of nitrogen, it can have carbon monoxide separately based on the meteorological dispersion parameters. So when a pollutant is here, how long it can travel, how long. So you can see here how these dispersions are normally well predicted using red, yellow, and blue and green color of the mappings. So this is a simple algorithm for using IoT and artificial intelligence into a network-based air pollution prediction and assessment. So this is the air pollution data. It's an algorithm. It's a wireless LAN network. It's an air pollution data acquisition system that it got the data, and it gives the meteorological parameters data. Then it predicts every meteorological parameters influence on the dispersion of pollutant, and then it can automatically give the maximum ground level concentrations in a particular environment. So this is particularly in the carrier center in Tamil Nadu Pollution Control Board. It's only the monitoring is done. But AI, cloud, and IoT enabled software-based air pollution predictions in industrial corridors, urban atmosphere, and traffic corridors can be synchronized and put together. So when I say traffic corridors, and I said the image processing analysis, and every automobile exhaust can be trapped the concentration of pollutants using sensors, There is a lot of remote sensors available to quantify the concentrations remotely while the vehicle is in moving conditions, and then it can automatically predict the automatically note the concentrations of the vehicle conditions, everything, and send a small notice to the particular owner, and the owner can come back and get it done. This is what an online-based monitoring and control system that I made. Creating the advanced air pollution Google thematic mapping for predicting eco-friendly routing to avoid heavy air pollution corridors. Automatic automobile monitoring, surveillance, and compliance system using IoT and cloud computing is very much essential. National and state level real-time ambient air pollution monitoring and predictions are being done through the software of cloud computing and IoT. So creating thematic mapping of red zone, green zones, yellow zones according to existing predicted real-time air pollution levels. So this is very important of making thematic air pollution mapping. So this is today the artificial intelligence can be leveraged to monitor, inform, influence, measure, detect, forecast, advise, reduce the and manage the air pollution problem. So the AI is very important, versatile tool that it can monitor, inform, influence, everything it can do, and if you are able to link it. Hence, the World Health Organization reports that 9 out of 10 people around the world breathe polluted air. And today, technology has become has enabled to help address air pollution. It can aid in better measurement, identify its sources, develop policies, and forecast and predict exactly before it happens. According to the report Greenpeace, 22 out of 30 world's most polluted cities are in India. So as per recommendations, according to the report Greenpeace, 22 out of 30 world's most populated cities are in India. As per recommendations, India requires a minimum of 4,000 air monitoring stations to check air quality, apply logic to the problem solving. Currently, there are approximately 160 air pollution monitoring stations in India. This implies we have less than 5% of the recommended number of air monitoring stations. So accurate computations of air quality not only requires combining existing air monitoring infrastructure with the satellite data, but also factoring in human activities such as traffic volume, traffic density, traffic count, and construction, garbage burning, industrial source apportionment, and population density. All these data to be integrated while we are predicting using the artificial intelligence. A future engineered artificial intelligence can be designed to utilize the above factors to accurately compute geospatial interpolation of air quality data. The advantage of such an approach is that it provides a distributed coverage of high and spatio-temporal resolution in near real time. For example, we could monitor whether an increase in industrial production is directly proportional to air pollution or decrease in vehicle is related to the reduction of air pollution. These decisions could be evaluated by artificial intelligence, allowing appropriate actions to be initiated. For example, we could monitor whether an increase in industrial air pollution production is directly proportional to the air pollution or decrease in vehicle related to the reduction. So this is a little algorithm. It is the IoT mobile air, and it's a big data predictive, and it's a cloud, and then it goes to the cloud, and then it goes to the fetching Google Map and mapping air quality index. So the like we plot a particular house to reach, how to go there, and it shows in red color, blue, yellow color. We can distinguish the air quality index, what we call AQI. It was well demonstrated almost 5 years before with the real-time air quality index. Like it's a mapping. You can pinpoint Bhopal, you can pinpoint Calcutta, and you will get a real-time air quality index whenever it is. That kind of a system, and that is instant, not predicted. As it is today, what is there, it will show you exactly based on the data availability. So this is again cloud, and it's called vehicular cloud for a vehicular pollution to control the vehicles, and the sensor can detect the automobile pollution. It can go to the central cloud, and it can then predict, and it can show you for 1 month, 1 week, or 6 months what could be the likely concentrations in that particular ambient as well as the auto exhaust emission load. It can calculate and give you based on the emission factors. So this is another algorithm. It's a data logger. It's a GPRS. It's an LED display, and then it is connected to the microcontroller. Then the particulate sensor, smoke, and carbon monoxide sensors are connected, and the output of the sensor, and the output of this digital computer system. Then the software can predict the model and make us a thematic mapping or the air pollution thematic mapping and send it to the Google, and the Google mapping can be done through using this artificial intelligence and cloud computing. So this is an IoT gateway. Normally we use it for data processing as well as predicting the air pollution concentrations. It's a machine learning embedded system. There's an IoT gateway that they make it. So IoT based air pollution monitoring, how they do it, you can see this is the IoT based sensor, this is the moderator, and then it you get it what kind of PM 2.5, PM10 air quality in humanity. All these data you will get it in every minute, every hour, or every 5 minutes. The data you can get it like in ECG, you will get it. So that's what I want to make it on IoT and the cloud computing and artificial intelligence based air pollution prediction system. It has very long way to demonstrate particularly. I thought to make it because to run it and show it to you, it will take an hour. That's the reason possibly. If anybody interested to know more or wanted to do with me on this particular topic, any industries or any pollution control board officials wanted to make it, please join with me on my email, pashanmugam@yahoo.com. You can go into the CLRA website and you can find out. And thank you very much. Thank you very much, Dr. Lima Rose. Thanks a lot for your time, and thank you very much. I think for around half an hour or so, I can take some questions. Hello?
Yes, sir.
Yes, you can take some questions for half an hour.
Yeah, you can ask questions to sir. Very informative and very well presented talk, sir. We thank you so much for your time and effort that you have made to give us such a beautiful talk. I request the participants to kindly ask some questions if you have.
Yeah, I could see Dr. Ature from CPCB, and I could see Babu from CPCB. There are many are online from Central Pollution Control Board. There are few available from the Tamil Nadu Pollution Control Board also. Like if you want to ask me any questions, please go ahead. You can send your questions to Professor Lima, and Professor Lima can read, and I can answer those questions.
They can ask. I have unmuted all of them. They can ask their questions directly.
Sir, if I want to check up randomly at random option or random position, then what would be what type of software I can use?
For random software, means just you want to check randomly in a particular location.
Yeah, I want to know the SOx NOx like that gases, emission gases.
Emission gases. Like there is one online digital repository by the Central Pollution Control Board. If the monitoring stations are connected to that particular location where you are looking for, directly you can, it's like ArcInfo and MapInfo software are well to predict nowadays on the location based or GPS based predictions.
If I am not connected, then how I have to do?
If you are not connected straight away, you can, but you cannot make online. If you are not connected to their any ISCST model, you can use and predict.
Okay, via the laptop, or I can install the online monitoring system.
Yeah, you can, but you need an access from the online monitoring agency,
Okay.
and you can connect through the GPS system. And if you can access their computer, access their data directly, and then you can access the med data also, then you can use, give your, first of all, you have to digitize it and show the mapping GPS system, GPRS system. Then once you give the GPRS system, the output of the CFD or output of the ISCST model can make you to get a mapping if you give a digitized map already imported onto, if you have a software of ArcInfo or map info.
Okay, by this we can analyze all type of gases like dioxane, methane, and all like that.
Yeah, we can analyze.
Okay, okay. Thank you, sir.
Thank you.
Otherwise, I will write down some message
Yeah,
to you.
please write down to me. Write down. My email ID is pashanmugam@yahoo.com and PASHANMUGAM Shanmugam@yahoo.com.
Okay, I will ask to organizer, sir. Definitely.
Yeah, please.
Okay, okay. Thank you, sir.
Thank you. Thank you.
Any other questions? So if there are no further questions, I think we'll thank Dr. Shanmugam again for spending so much of his time and giving us a very good talk about how we can use the programming and the latest artificial intelligence and Internet of Things and all the others, along with programs that I mean, most of us are familiar with, like CFD modeling and so on. So we thank you once again, sir, for having accepted to give your talk and given us a very good and informative lecture on how we can use the latest technology for monitoring the air pollution and how we can use it for controlling. Thank you, sir.
Thank you. Thank you, Professor Lima. Thank you for your nice invitation. And I'm quite excited and really enjoyed with the participants. And it was a nice subject that I could make it. Any questions? Come. The organizer can get the questions and you can send it.
Yes, sir. Yes, sir.
Thank you, ma'am. Thank you very much.
If they give me any questions, I can send it to you, sir, or you can leave as of now. So now we come to the last part of the program, or last but one part of the program, where I would like to get a feedback from you. Before you should also be knowing that you have to give the feedback in the Atal portal regarding the different sessions and how it was conducted and so on. So that is what you have to do. But I would also like to get a feedback from you regarding this FDP program. So if a few of you can talk now, because this is there's nothing theoretical about it. It's only your opinion, and it will help us to make changes in the future and make a better program. So if you have any suggestions, any comments, I would welcome you to make those comments.
Yeah, myself, Dr. Sudesh Kumar here from Vanasthali Vidyapeeth.
Okay.
Ma'am, you have in a very successful manner this conference, and all the speakers were excellent. They have deeply knowledge about their criteria, their research field, and their even they were also good teachers. Even they belongs to some consultant and some research area.
Yes, sir.
We have enjoyed we enjoyed all the session a lot of.
Yeah, I hope you've got all the
Yes,
YouTube. I mean, we put it on the YouTube, so the recording also is there for you all. You can use it because I know everything we can't retain in the mind. And some of the PPTs I'll see because they've requested me to make it into PDFs before I share it. They don't want it to go as PPT. So I'll try to, I have to look into that also. So I think the YouTube video should be good enough for you to learn whatever you want to learn. And their contact information, if you want to contact anybody, you can also get back to me. Anybody else has anything else to say?
definitely, ma'am. One more request, ma'am, from my
Yes.
end. Please convey the email and contact number of the resource person so that we can get benefited in future also
Yeah,
from
you know
your
what?
side.
We have the group, right? We have
Yeah.
the group that is there.
Yes, ma'am.
So I will share the email ID of all the speakers with you, and you can get in touch if whenever you think they will be able to help you. Because most of
Okay.
them you can see are very are wanting to share the knowledge that they have gained. Most of them are very senior and have been working in the field for very long. So it'll definitely help you out, and I will share the email ID of all of them with you.
Yeah, definitely. Thank you, ma'am.
Yes. Anybody else? Any other comments? I would like some negative comments also. And one comment, it's like, whenever we want to purchase anything on the web, we normally look for reviews, right? And if only one or two people have put review, we normally don't even open that because we want more number of people to review, and then we can see what everybody has to say. So when there are 50 odd people, I would like at least 5 or 6 people to make comments on whatever the program was. Okay, if there are no comments, I on my part will like to give a few comments. First and foremost, I have to thank one of my colleagues who was actually instrumental in making me apply for this ATEL program. I wouldn't have done it otherwise. So without her initiation, without her active support, I wouldn't have gone into doing this. So I thank her. She's there in the group, so she know I'm talking about her. So all the hard work that was done was essentially by her. Maybe I just got the speakers, okay, to give the talk, but other than that, all the filling up, all the other things was done only by her and the students. So I thank them a lot. Actually, basically, what I had is my personal opinion is a lot of theory we know. Okay, as teachers, a lot of us know at different levels. Okay, I'm not telling we know everything. We know information to different levels, but we really don't know how the industry looks at it. For example, if you saw when Dr. Anand spoke, the more importance it was given is not so much for technology, but for the process that would take the least amount of cost and give you the best output. So okay, so I don't think when we do research, we keep that in mind. We don't bother about how much distilled water we use, how much of chemicals we use, and so on. So I wanted people or all the faculty to be also aware that there is another side that we have to look into if we really want to commercialize our process.